Hello everybody, Mr. Alent here. I'm going to work on some examples from Chapter 9, Section 1. Because the length that YouTube is allowing us to put videos, only 15 minutes, I'm going to have to break this up into a couple parts. So I got 4 examples I want to show you for Section 1. Then I've got examples for Section 2 that I'm going to show you. So we're going to have several little videos here broken up, and we'll just do the best we can. Sorry about that. So as far as the first one here, when you're solving these, what you want to remember, I put 3 notes at the top up there. And what those are the things you want to think about when you're doing every one of these problems. So the first step is to identify the shape and the formula that's needed. Okay, so shape and formula that's needed. We saw yesterday, if I pull this up for you, right? We saw yesterday all these different shapes. We had formulas for perimeter, for area. So you're going to identify which of these it is that you need to complete the work for the problem. Then step 2, find all the needed pieces. Now, sometimes you're going to be missing stuff. You're going to find the right formula, but you're not going to have all the information for each problem to just jump right in and do it. So you're going to have to do a bit of work to solve, and that's what this says. You're going to find all the needed pieces. You may have to use trigonometry, remember sine, cosine, tangent, or you may have to use Pythagorean theorem. A squared plus b squared equals c squared for right triangles. So you're going to find those missing. Once you have all the pieces, once you know everything that you need for the formula, then you can plug it all in. This is what I call it plug and chug, right? So you're just going to plug it in, put all the stuff in there, put the values into the formula, and then solve, and just chug away at the arithmetic, okay? So let's see an example here. It says, find the area of the parallelogram to the nearest tenth. So here's our parallelogram. And so, all right, step 1, identify the shape and formula needed. We're talking about area, and we're talking about the shape as a parallelogram. So we're going to have to get the area formula for parallelograms, right? And so we look over here at our area and perimeter formulas, right? We're talking about a parallelogram, and we're talking about area right here. Area equals base times height. Now, remember from the previous video, the base of a parallelogram is where you draw the height to. It's the side you draw the height to. So this is a base, but also you could consider the top the base. And they're the same length, right? We said for parallelograms, opposite sides are congruent. So these are the bases in this picture, and then the height is how far apart they are. Okay, so let's write that formula out. Please do this. Write out the formula. It's super, super helpful to write the formula out at the beginning. And then you start to substitute in what you need. You can see the pieces you have and which ones you got to find. Okay, so we're now looking at the picture, and we need to find the base. Now, here's where we need to be a little bit careful. It looks like the base is 9, but that is incorrect. That is false. It's deceiving you. The base is actually the 6 up here. That is our base. Now, why? Why is the 6 the base? Well, the height's a little bit weird. They drew the height outside of our triangle here, which is a little bit weird, but if I were to draw it inside, like that, that's still the same height. I mean, those look the same length. They are the same length, right? So they just happen to do it outside. And so remember, for parallelograms, opposite sides are congruent. So if this is 6 up here, then this has got to be 6 down here. So what's this 9 referring to then? Well, the 9 is including that dashed piece, right? So from the end to end with that dashed piece, that's where the 9 is coming from. So that's not what we care about for the base of our parallelogram. So the 6 is the base, and that's going to go in there. Because this is 6 centimeters from here to here and 9 centimeters across the whole thing, we do know that this little guy here is 3 centimeters. Okay, that's an important piece we'll need to know. And then also, we did say again that opposite sides are congruent in parallelograms. So if that's a 5 centimeters over there, then that's 5 centimeters also. Okay. So what I'm looking at here, then I've got this little right triangle, right? We need h. We got to have h in our formula, and we don't currently know it. But I see a right triangle, all right? This is coming down at a right angle, So this is a right triangle where I know a leg and I know the hypotenuse, and I'm looking for the other leg. That is a prime Pythagorean theorem problem, right? Anytime. And by the way, guys, please note that in your brain whenever you're working, if you know two sides of a right triangle, you find the third side with the Pythagorean theorem every single time. Okay? If you know two sides of a right triangle, find the third side with Pythagorean theorem. So we're going to use Pythag theorem. I always just abbreviate it. Pythag theorem to find h. Use Pythagorean theorem to find h. So I'm looking at this right triangle again. Pythagorean theorem is a squared plus b squared equals c squared. But what you have to remember about that is that a and b are the legs and c is the hypotenuse. And so what I prefer to say is actually leg squared plus leg squared equals hypotenuse squared, right? So a leg is 3, so I'm going to square that, 3 squared. I'm going to add to that, right, a squared plus b squared, and b is a leg, so the h is a leg. Remember, the legs are what make the right angle. The hypotenuse is the side always across from the right angle. And the c part of the a squared plus b squared equals c squared is the hypotenuse. And that gets squared also. Okay? So then how do we solve a Pythagorean problem like this? It's actually very simple. You're solving for the variable. Solve for h. When you solve for a variable, you need to isolate it, we call it. You get it alone. So everything's got to move away from it. And the first step would actually be to square the things we can, right? 3 squared, we know that. That's 9. All right, h squared can't do anything with it yet. And 5 squared is 25. Okay, and now again, we're solving for h. So stuff's got to move away from h. So let's subtract 9 from both sides. We're going to get h alone. 25 minus 9 is 16. Okay, now we have h squared, but we don't want that. We want h, right? H equals, not h squared equals. So we have to think about how do I undo squaring? What's the opposite of squaring? The opposite of squaring is square rooting. So I square root both sides. Square root of h squared is h. Great. Square root of 16 is 4. And now I have what I need, right? We knew b, it was 6 centimeters. And now we've found h. We can go ahead and plug them in and finish this problem out. Here's that plug and chug, right? So plug in b is 6, plug in h is 4. Chug just means do the arithmetic. 6 times 4 is 24. It said round to the nearest tenth. No rounding necessary. It was a nice even number. 24. And then think of the units. Everything was in centimeters, but we're talking about an area. So it's centimeters squared. You need that little square there. And remember our talk yesterday. Area is how many 1 by 1 squares fit into that space for that unit. So in this case, 24 1 centimeter by 1 centimeter squares would fit into this parallelogram. Okay? So there's one example. We had to find the height to be able to finish off. Let's look at example 2. Now this one's a toughie. This is probably the hardest type that we give you. And it's really not too bad, just kids get bogged down and forget the little things. And so let's see what we can do to stop us from doing that. It says we're going to find the length of the rectangle. So we're talking about a rectangle. There's our shape. With a width of 3x inches and an area of 6x squared minus 24x inches squared. So this one's what we call a working backwards. So I'm going to say we call this working backwards. And why is it working backwards? It's because we know the area, right? It gave us the area right here. The area is, right, 6x squared minus 24x square inches. And we're trying to find the length. So we're looking for one of the pieces given the area. And we are given also the width of 3x. So it's a working backwards. But the key, though, we're talking about area, we're talking about rectangle. So when it comes to, right, identify the shape and formula, we're doing a rectangle, talking about area. And the formula for that is that really nice and easy, right? Area equals length times width for a rectangle. Right, again, that's coming off that previous page in another video. So here's what we do from here. And again, yes, write the formula. Because now what we're going to do is take the pieces we have, substitute them in. So area of, that's the A. Capital A is this. 6x squared minus 24x. Okay, and I'm going to leave off the units. I don't like to work with the units while, you noticed over here I didn't put in the units. I just plug the units in at the end, knowing what we're talking about. So keep the, so that way it's not too confusing of what's happening with those units, those inches, and so forth. Okay, and then as far as our formula, right, we're plugging in stuff. So the L, that just stays as L. That's what we're looking for. L is L. And then times the width of 3x. And yes, you've got to put the x's in. Yes, okay. So there's the setup. That's how every working backwards is gonna go. You're gonna write the formula, plug in what you know. Now the key is, and this is where kids get thrown off, because we're so used to solving for x. Some of you are gonna think, okay, I need to solve for x here. And that is incorrect. We didn't ask you to find x. We said find the length. Find the length. So you are solving for L. And since we're solving for L, again, solving means isolate, get it alone. So we need to get rid of this multiplication of 3x. How do you get rid of multiplication? By division. You divide by 3x. Okay? Now doing so, right, clears those 3x's out, and you just have, I'm going to kind of flip it. I'm going to put my L equals. You've got L equals. And then over here, now what I'm going to do here, I'm going to, when you divide the whole side by something, really each piece gets divided. So I'm going to break it up and show each piece being divided by 3x. Right? The whole side's getting divided, so each piece gets divided. Each piece gets divided. And that's so that we can see kind of what's about to happen a little bit better. Because when you're dividing here, you can just start kind of breaking up numbers and variables on their own. So like, what is 6 divided by 3? Well, that's 2. What's x squared divided by x? That is just a single x. Okay. And then we have a minus. We have 24 divided by 3. That's 8. X divided by x is 1. Right? X divided by x is 1. Anything divided by itself is 1. So don't care, because then it'd be like 8 times 1, which is just 8. So my length looks like it's 2x minus 8. And this is where it's weird. You're done. Stop. There's always this desire to move on and solve for x. No. We wanted you to find the length. We've got it. 2x minus 8. So put it in parentheses and attach the unit inches. The reason we put it in parentheses is to say that this whole big ugly thing is representing some inch value. And that's it. That's done. Now you can always check your work to see how you did. Real quick, you go back to the area formula. Area is length times width. All right, you just found the length of 2x minus 8, and we had the width that was given of 3x. So if I were to multiply, I would distribute this 3x through and multiply each piece. 3x times 2x is 6x squared. 3x times a minus 8 is a minus 24x. And that's what we had. That was the area that was given at the start. So you can check your work and make sure you did it right. Okay, I'm going to stop this video here, and I'll do a couple more examples in another video. All right, guys.